Have you ever found yourself just trapped in that digital loop? Endlessly clicking through web forms, maybe copying data meticulously from one page to another, or, manually verifying every single feature after new code deployment. It's not just, soul-crushing busy work. It's a massive drain on time. And let's be honest, it's where errors creep in. It's like being forced to be a robot, but without any of the actual efficiency. Well, imagine a powerful alternative. That's really the promise of browser automation. It's a way to programmatically command a web browser, basically simulating human interaction tirelessly and with perfect accuracy. Think of it like having your own digital clone handling all those repetitive online tasks for you. It frees you up for the work that actually needs your brain. So our mission for this deep dive is really to equip you with the knowledge to move from those, tedious manual clicks to a state of automated mastery. We're going to explore how these cutting-edge tools are helping developers reclaim precious time, drastically improve accuracy, and ultimately just supercharge productivity. By the end of this, you'll have a really comprehensive understanding, hopefully empowering you to tackle some real-world challenges with automation.
Exactly. And we're going to sort of guide you through this whole journey. We'll start by unpacking the fundamental why and what of browser automation, get the basics down. Then we'll navigate that crucial decision, choosing the right modern tools like Playwright, maybe over some of the established ones. From there, we'll roll up our sleeves, dive into building some real-world applications, think web scraping, robust end-to-end testing. And finally, we'll even look at automating the automation itself by integrating with CI/CD pipelines. It's quite the trip.
We've all felt that pain, the digital drudgery. But let's zoom in for a second on why this is such a pervasive problem, particularly in modern software development. What are the core challenges that browser automation really tackles head-on?
Right. Well, the biggest pain point I think that browser automation alleviates is just the sheer bottleneck created by repetitive browser-based tasks. It's huge. Imagine replacing weeks, literally weeks, of manual QA work with an overnight script, or gaining real-time market intelligence that was simply impossible to gather before. That's the real shift.
Yeah, that's a massive change.
It really is. Browser automation enables this kind of stuff. It collapses time and expands what's possible. It offers a programmatic, sort of hands-off way to control web browsers, simulating human clicks, form submissions, navigating pages. This directly addresses those bottlenecks, saving valuable time and, crucially, improving accuracy across the board.
That sounds incredibly powerful.
Mm-hmm.
Okay, so let's unpack this a bit more. Let's look at the three main pillars of browser automation. And as we go through them, I'd encourage you, the listener, to think about how these could apply to your own work, or maybe just things you're curious about online. So the first pillar, web scraping. This is all about automated data extraction from websites.
Yeah, and a key aspect here is its versatility. Web scraping is basically the engine behind gathering product prices, tracking market trends, maybe aggregating news from various sources, or even collecting customer reviews to gauge sentiment. It's particularly valuable because it's not just for static pages. It's fully capable of interacting with and extracting data from complex modern web apps, the ones that load content dynamically using JavaScript.
Ah, so it handles the tricky stuff too.
Exactly. Stuff that a simple API might not expose. You can get data that's only visible after you click around a bit.
Got it. Okay, and the second pillar, end-to-end testing, or E2E testing. This means automating complete user journeys through a web application.
Right, and this raises an important question. Why is E2E testing so critical? Well, it's because it simulates a real user. Logging in, adding an item to a cart, completing a purchase, that whole flow. This ensures that all the integrated components of your application, the UI, the backend, the database, they all function correctly together. It's a vital practice for verifying application quality and, importantly, for preventing those pesky bugs, those regressions, from ever reaching your users.
Sort of like a final quality check before release.
Exactly. Think of it as your last line of defense before a bug escapes into the wild.
Okay, and finally the third pillar, robotic process automation, or RPA. This is where browser automation gets applied to execute broader business workflows. Yeah, RPA offers some really tangible benefits, especially for organizations maybe dealing with older systems, legacy stuff. Imagine automated data entry from web forms straight into a legacy database, or generating reports from web-based dashboards that, don't have an export button.
Oh, I've seen those.
Right. Or even processing invoices by extracting information from web portals. It's particularly valuable for businesses needing to integrate with legacy systems that just lack modern APIs. It becomes a powerful bridge builder for older tech stacks, basically.
Okay, that makes sense. So with all that power on the table, the critical question becomes,
If you're starting a new automation project today, which tool do you pick? For years, Selenium has been the established standard. But Playwright, a newer framework for Microsoft, has been gaining serious traction really fast.
Yeah, and the core distinction between them, it truly lies in their underlying architecture. And this design choice has profound implications for, like, performance and reliability.
Yeah.
Selenium uses the WebDriver protocol. Now, that's a W3C standard, which sounds good, right? Industry agreement.
Standard sounds safe.
It does, but it acts like a middleman. It sends commands from your script as individual HTTP requests to browser-specific drivers. Think of it like making a brand new phone call for every single click or interaction your script needs to do.
Oh, okay. Lots of overhead.
Exactly. It creates inherent latency because each interaction requires a whole new request-response cycle. It adds up. Playwright, on the other hand, takes a more modern approach. It communicates directly with browsers using their native DevTools protocols, like the Chrome DevTools protocol, over a persistent WebSocket connection.
A WebSocket, like a continuous open line.
Precisely. By maintaining this single, long-lived connection, Playwright eliminates the overhead of setting up new HTTP requests for every command. This direct line means significantly lower latency and much faster execution speeds, especially noticeable in larger test suites with lots of interactions.
Okay, so it's like switching from dial-up to fiber optics, maybe.
Yeah, that's a pretty good analogy, actually. It's just a fundamentally faster, more direct connection.
That direct connection sounds like a massive performance boost. But beyond just raw speed, does that architectural difference also simplify the development experience or make tests more reliable? Because you mentioned reliability is key. It feels like it embodies that shift-left idea catching problems earlier in development. So what does that mean for your workflow in practice?
Absolutely. It impacts reliability hugely. Let's do a quick rapid-fire comparison of key features that really affect your day-to-day development. Performance. Like we said, Playwright is generally much faster, especially running headless. Selenium is inherently slower because of that WebDriver overhead. Auto-weighting. This is a big one. Playwright has built-in intelligent auto-weighting. It waits for elements to be ready, like visible and clickable, before acting. This drastically reduces flaky tests.
Ah, flaky tests, the bane of every tester's existence. Those ones that randomly pass or fail.
Exactly. Like a faulty light switch, super frustrating. Selenium often requires you to rate explicit or implicit weights manually, which is a primary source of that flakiness. It's a huge difference in practice. Set up an installation. Playwright is simpler here, too. A single Playwright install command bundles all the necessary browsers for you. Selenium historically required separate driver management. Selenium Manager has improved this recently, but Playwright's approach is still generally smoother. Tooling. Playwright comes with fantastic built-in tools. Cogin helps generate test code, Inspector lets you explore selectors, and TraceViewer is amazing for debugging failed tests. Superior developer experience, really.
So better tools baked right in.
Yeah. Selenium relies more on external tools or plugins to achieve similar functionality. API testing. Another advantage for Playwright, it has native support for making API requests within the same framework. This allows for unified UI and API testing in one place. Selenium is purely for browser automation. You need other libraries for APIs.
Wow, okay. So if we're talking verdict here, the sources seem pretty clear. For most new projects, especially with modern web stacks, Playwright's architecture, its speed, those reliability features like auto-weighting and the developer tools, they just make it the more productive and, well, superior choice, wouldn't you say? Feels like a genuine step up.
I'd agree. For new projects, it's generally the way to go. The advantages are quite significant.
Right. Now let's talk practicalities. You're convinced you want to try it. How do you actually get started with Playwright and Python? What are the first steps?
Okay, yeah, setting up a robust development environment is crucial. Avoids headaches later. First, you'll obviously need Python. Version 3.8 or newer is recommended. Then, super important, create a project directory and a virtual environment inside it. Python-venv, and then activate it. Source venv, bind activate on Linux, Mac, venv scripts activate on Windows. Keep those dependencies isolated.
Always use a virtual environment. Good advice.
Always. Then, installation, pip install pytest Playwright. That integrates Playwright nicely with the pytest testing framework. And here's that big advantage over Selenium again. Installing the browsers. Just run Playwright install. Boom. It downloads Chromium, Firefox, and WebKit for you. No manual driver hunting.
That is much simpler.
It really is. For project structure, a good practice is a test directory for your test scripts, maybe a pages directory for page object model classes. We'll talk about those later. And put an empty init.py file inside pages so Python treats it as a package. basic Python stuff.
Got it. So once that's all set up, what's the hello world, the first simple test to make sure everything's working?
Right. The equivalent is usually a quick script to verify a website title. You could create a file, say test.initial.py, inside just a few lines, import Playwright stuff, define a test function, use page.goto to navigate to maybe playwright.dev, and then use an assertion like expect page.toHaveTitle, ae.com Playwright. It checks if the page title contains Playwright. Simple, but confirms your setup is good to go.
And that's all sanity check.
Exactly. And that first test introduces the 3 fundamental Playwright concepts you'll use constantly: locators, actions, and assertions. Locators are how you find elements on the page. And the best practice here is really to use resilient, user-facing attributes. Think roles, text content. For example, page.getByRole, button, name, sign in. Much better than relying on fragile CSF selectors or XPath that might break easily if the site changes.
More robust, less likely to break.
Yes. And crucially, locators in Playwright represent a query for the element, not the element itself. This allows Playwright to requery the DOM dynamically if needed, adding to that reliability. Then you have actions. These simulate user interaction.page.goto.click.fill for typing into fields, etc. And this next part, the auto-weighting, is honestly where Playwright just shines. It solves one of the biggest headaches in automation.
You mentioned this earlier, the flakiness problem.
Right. Playwright's intelligent auto-weighting performs these actionability checks. Is the element visible? Is it enabled? Is it not covered by something else before it tries to interact? This eliminates the need for those awful manual sleep statements or complex explicit waits that plague other frameworks. I mean, the hours I've lost debugging flaky Selenium tests.
We've all been there, trying to guess the right wait time.
Exactly. Is it 1 second? 2 seconds? Playwright just handles it automatically. It waits until the element is actually ready. It's almost magic. And finally, assertions. These are your checks. They validate the state of your application using Playwright's expect function. And these are web-first assertions, meaning they automatically wait and retry until the expected condition is met or until a timeout is reached. So expect locator.toBeVisible won't fail instantly if the element isn't there yet. It'll wait a bit, retry, making your tests way more reliable, especially with dynamic content loading on modern sites.
Okay, those 3 locators, actions, assertions with auto-weighting built in. Seems like a solid foundation. So with those fundamentals understood, let's shift to a practical project. Let's talk about the art of web scraping. We'll look at an example targeting e-commerce test site, https://webscraper.io test-sites-commerce Scalenium. And the objective is clear. Extract product names, prices, descriptions, and then save all that data to a CSV file.
Right. And the real power of Playwright here, especially for scraping, is how it handles the modern web, dynamic content, stuff loaded with JavaScript, pagination. Because it interacts with a fully rendered browser, it executes JavaScript just like a real user would. It sees what the user sees.
So it doesn't get tripped up by sites that load data after the initial page load.
Precisely. No more trying to parse half-loaded HTML or reverse engineer API calls. Playwright just deals with the final rendered page. Much easier.
Okay, so the scraping process in the source we looked at involves opening a browser, navigating to that test site, and then using Playwright's locators, those robust ones we talked about, to find the product details, like maybe a .title for the name, h4.price for the price. This sets up the core logic.
Exactly. You locate the container for each product, then find the specific elements within it. But then comes pagination. Mastering pagination is critical for comprehensive scraping, especially on sites with, hundreds of products across many pages. The robust strategy involves a while true loop. Inside the loop, you systematically check for a next button. You might use page.locator to find it. Then, critically, you check if it's visible using .isVisible. If it is, you click it. If not, you've likely reached the last page, and you break the loop.
Makes sense. Keep clicking next until there's no next left.
Right. But here's another key part for reliability: synchronization. Instead of using a fixed time.sleep, after clicking next, which is brittle.
Yeah, what if the network is slow?
Exactly. You use something like page.waitForSelector, devv.thumbnail, state visible. This tells Playwright to pause the script until it actually sees the product elements rendered on the new page. This ensures your scraper is always perfectly in sync with the application state, preventing missed data or errors caused by scraping too early. Much more robust than guessing with sleep.
That's clever. Wait for evidence the next page loaded correctly. Okay, so you've looped through all the pages, scraped all the data. Now you need to save it. persist it, usually to a CSV file, right?
Yeah, saving is the crucial next step. You can certainly use Python's built-in CSV module. It works fine. But honestly, for data-centric tasks like scraping, the pandas library is really the pro's choice. It's incredibly powerful. You can easily convert your list of scraped data, maybe a list of dictionaries, into a pandas data frame. And then saving it to CSV is super concise. Something like df.tscsv, products.csv, index, false, encoding do-fate, just one line.
And Pandas gives you lots of other data manipulation tools too, right?
Absolutely. It's not just simpler for saving, it opens up a whole world of data cleaning, analysis, and manipulation capabilities right away. Makes your scraped data much more useful, much faster.
Okay, cool. So we've seen how Playwright can pull data from the web effectively. But what about pushing the boundaries of what your applications do, validating behavior? Let's pivot now from just extracting information to rigorously testing how your entire application behaves from a user's perspective, using Playwright for end-to-end testing. Our example application for this part is https://bstackdemo.com, another test site.
Right. And this shift towards testing leads us directly to a really important design pattern. The page object model, or POM. It's like the blueprint for maintainable tests. Let's talk about the problem POM solves first. If you don't use it, you end up hard-coding selectors, those page.locator strings directly inside your test functions.
Like page.locator, #login.button.click, right in the middle of the test logic.
Exactly. Now, imagine that #login button ID changes slightly in the next UI update. You'd have to hunt down and fix that locator string in every single test that logs in.
Ugh, yeah. That sounds like a maintenance nightmare, especially with lots of tests.
It absolutely is. It quickly becomes brittle, unreadable, and just a huge pain to maintain. So the solution is POM. It centralizes all the locators and the interaction logic for a specific page, like the login page or the home page, into a single Python class that's your page object. So the login page class would have the locator for the username field, the password field, the login button, and maybe a login method that performs the actions.
Ah, so all the details about how to interact with the login page live in one place.
Precisely. Now, if that login button ID changes, you only fix it in one place, the login page class. All the tests that use the login page object automatically get the fix. The benefits are huge. Clean separation of concerns, test logic versus page interaction logic, dramatically more robust tests, much more readable tests, and infinitely more maintainable tests. Your tests end up focusing on the user journey, the what, not the nitty-gritty UI implementation details, the how.
Okay, I can see how that makes tests much cleaner. So you'd have that pages directory we mentioned earlier, with classes like login page, homepage. Each class holds its locators and methods like login, user, password, or add product to cart, product name. Then in your test directory, your PyTest files, test_login_flow.py, test2purchaseflow.py, would import these page objects. And the test itself would look like login page.login, user passcode, then homepage.add, product to cart. Cool gadget. Very readable.
Exactly. The tests read like a sequence of user actions, hiding away all the locator complexity inside the page objects. It's the standard for serious UI automation.
Right. Now, running tests manually on your machine is fine while you're developing. But how do you scale this for a team? How do you ensure tests run consistently? How do you automate the automation?
Good question. The answer is continuous integration, or CI, and its value is immense.
So automatically running tests whenever code changes.
Yes. CI servers automatically run your test suite on every code commit or pull request. This provides incredibly rapid feedback, instantly if a change broke something. It acts as a critical quality gate, preventing bad code from getting merged. And it ensures your test suite itself remains stable and runnable. No more, it works on my machine, excuses.
Yeah, that's a big one. So how do tools like GitHub Actions fit in?
GitHub Actions is a perfect fit here. It's a CI/CD platform that's deeply integrated right into GitHub, where your code likely lives anyway. Your entire CI process, building, testing, deploying, is defined in a simple YAML file, usually called something like playwright.eml, located in a .github workflows directory in your project repository.
Okay, so it's code defined in the automation pipeline itself.
Exactly. Infrastructure as code, but for your testing pipeline.
So what does that playwright.iml file typically contain? What are the key parts?
Well, it defines when the workflow should run, usually on push to your main branch, or on pull request targeting main. So run tests before merging. It defines the job, like jobs.test, specifies the runner environment, usually runs on .bin2latest, and then it lists the key steps. First, actions checkout at v4 to get your code, then actions setup Python at v5 to set up the right Python version, then pip install -r requirements.txt to install your project dependencies, including PyTest Playwright. Crucially, Playwright install with dets to install the Playwright browsers and their operating system dependencies within the CI environment.
So the CI runner needs the browsers too. Makes sense.
Yep, and finally, the command to actually run the tests, usually just PyTest, it's a full automated setup defined declaratively in that one YAML file.
That's pretty neat. Okay, but here's a common CI/CD challenge, right? When a test fails in the cloud, in that GitHub Actions runner, it often feels like a black box. You just get a red X, maybe some logs, but it's hard to see what actually went wrong visually.
Yeah.
How do you debug that effectively without being right there?
That is a classic problem, and the solution is capturing and uploading test artifacts. This is where Playwright's tooling really shines again. When a Playwright test fails, it can automatically generate incredibly detailed HTML reports, take screenshots at the point of failure, and even record full execution traces.
Execution traces, like a video.
Sort of, but much more powerful than just video. We'll get to that. The crucial step in your GitHub Actions workflow file is to add the Actions Upload artifact at v4 step and set it with if always.
It's always. Why always?
Because you want the reports uploaded even if the tests fail, especially when they fail. That's when you need the debugging info the most. If you only upload on success, you lose all the failure diagnostics.
Got it. Good tip. So the artifacts get saved even on failure.
Right. It's like having a flight recorder for your test run.
Okay, so this enables a powerful remote debugging workflow. Let's say a test fails in Actions. What do you, the developer, do next?
So, you go to the completed GitHub Actions run page for your failed build. You'll see the Playwright report artifact listed there. You download that artifact, which is usually a zip file, unzip it. Inside, you'll find an index.html file. Open that in your local browser. That gives you the full HTML report, which tests passed, which failed, error messages, maybe screenshots.
Okay, that's already helpful. But you mentioned traces.
Yes. For the really deep analysis, look for the trace.zip file within that downloaded artifact, or sometimes alongside it. This is the goldmine. You can then use the Playwright Trace Viewer. You can either install it locally and run npx playwright show report path to downloaded report, which often includes the trace, or even easier sometimes, just go to trace.playwright.dev in your word browser and upload the trace.zip file directly there.
And what does this trace viewer show you?
Oh, it's amazing. It provides a full time-synced view of the entire test execution. It's not just a video. You get a screencast showing what the browser displayed. You get a list of all the actions Playwright took. You get DOM snapshots before and after every single action.
Wow, DOM snapshots. So you can see the HTML structure exactly as it was.
Exactly. Plus, you get console logs from the browser and all the network requests that happened during the test. All perfectly synchronized on a timeline. It allows you to step through the failure with incredible precision, seeing exactly what Playwright saw and did and what the application state was at the moment things went wrong. It's like debugging live, but after the fact.
That sounds incredibly powerful for diagnosing those tricky CI failures. Takes the guesswork out.
It really does. It transforms debugging from a black box mystery into a transparent process.
So there you have it. We've really covered a lot of ground. We've journeyed from, recognizing the sheer drudgery of those manual online tasks, all the way to unlocking the power of automated mastery using Playwright and Python. And with the skills we've explored today, web scraping effectively, building robust, maintainable end-to-end test suites using the page object model, and integrating all of that seamlessly into a professional CI/CD pipeline with GitHub Actions, complete with powerful remote debugging. You're truly, I think, poised to revolutionize your development process. You're well on your way to becoming a browser automation specialist.
Absolutely. And to keep pushing your expertise further, maybe consider exploring visual regression testing. Playwright has a built-in to have screenshot assertion. This is incredibly powerful for catching unintended visual changes like subtle CSS regressions where a button moves slightly or colors change unexpectedly. It compares current screenshots against a known golden baseline image.
So catching bugs that functional tests might miss.
Exactly. Bugs that affect the user experience visually. Or, for a completely different kind of challenge, if you're really into scraping, you could dive into advanced techniques. Things like automatically solving KPCHAs, which is tricky, or managing IP based rate limits using rotating proxies, which is essential for really large-scale data extraction projects without getting blocked.
So always more to learn.
Always. The field is constantly evolving.
Well, we strongly encourage you to take these powerful new skills, Playwright, POM, CI/CD integration, and start applying them to your own projects. Experiment, build things, automate the annoying stuff. The world of automation is vast, and hopefully this deep dive has given you a solid foundation to continue your learning journey.